Hello students. So in the next lecture we are going to start with what we have done in the previous lecture, that was absorption laws. So what I'm going to do is to revise this law again because this is of utmost importance. First law which we discussed was Lambert law, and the second law we discussed was on Beers law. So in the coming lecture, we are going to solve some kind of problems based on this Lambert Beer law. So what in the starting I'll do is I'll revise the concept of this law, and then we'll go ahead with some kind of numericals based on Lambert Beer's law. Just to remind you that it was all about finding the absorbance of a particular radiation. So a particular wavelength light, if it is absorbed or not, what is the percentage absorption, what is the percentage transmission, that is what we want to know. So we have to use this kind of cylinder which you call it as cuvette. In the cuvette we have to put this sample, and the sample would be having some kind of molecules in it, and then when you allow the light to pass through it, incident light with intensity I naught, if you allow that light to pass through that cuvette, these particles are going to absorb some light. They are going to interact with that light, and that interaction of light with matter is spectroscopy. So in spectroscopy, Lambert Beers law is having an importance and an application at the same time. So when you allow the light to pass on the sample interact, and that interaction we have to measure in terms of absorbance, and then whatever is coming out after absorption, whatever intensity of the light is coming out, that light you'll call it as a transmitted light, and that we may observe in terms of percentage also. So let's say if 70% light is transmitted, that directly means that 30% light is absorbed. So in Beers-Lambert's law, they said two things. That first law said that it is proportional to the path length, means this L, whatever is the thickness of this cuvette, it is proportional to that L. And the second law says that it is also proportional to the concentration. Decrease minus represent decrease. So decrease in the intensity of light, I0 is definitely greater than that of I. That means there is decrease in the intensity. So Lambert says it's because of it is proportional to path length. If you increase the path length, decrease would be more. And similarly, it depends on the concentration also, because the number of molecules increase if I increase the concentration. And based on that, we devised this law wherein absorption is equal to Cl, and epsilon is molar extinction coefficient. That is a coefficient which we have introduced. So in the very next lecture, we are going to solve various problems, and we are going to use this equation in order to solve those problems. So see you in the next lecture. Thank you.